One of the most challenging tasks for teachers in the projects is to develop creative ideas. Although the education system, especially in Turkey, has slowly begun to depart from the traditional approach in recent years, the fact that our education system is based on the linear structure, and it can be argued that hinder creativity. It's just like that. If we want our students to be creative, just we can say that be creative. Is it okay or not? Our main question is about that. We know that the creativity mostly depends on the generation of new ideas, and presenting the evolution of different ideas are associated with the ability to think in terms of variables is really important for the foster creativity. We know that an iterative structure should be followed in teaching, like engineering design or scientific processes that comprise creativity. It may be possible that there are multiple solutions to design-related problems. Yes, and also we generally ignore that our students' emotions about learning. And if we combine the emotions in the process, we can foster creativity. In this context, this study primarily presents a theoretical framework regarding the nature of engineering design and how it can be integrated in the classroom practices. Then a model for teachers on how to develop and carry out design-based classroom activities that will improve students' capacity of thinking like an engineering is proposed. Yes, simply we can define the engineering design like is performing the act of design under certain constraints. However, this general definition actually encompasses many concepts and skills such as creativity, determination, systematic thinking, and cooperation. You can see some designs in this picture. For example, you can see the airplane. It's an original design, and it's really need to use some creative skills. Yes. Actually, we should know about the scientific inquiry and engineering design. Sometimes engineering design is generally associated with the scientific inquiry due to its problem-solving nature. It will be beneficial for understanding the reason for the establishment of association to reveal distinctive characteristics of both the engineering design and the scientific inquiry. You can see some characteristics of the scientific inquiry and engineering design. Yes. Now, in our model, we use three basic elements. One of them is engineering design. You can see here, ask, imagine, plan, creative, create, test, and improve states. It's an iterative process. And we use science, technology, engineering, and math integration. It's about to put some STEM skills and knowledge in the projects and minds-on and hands-on activities. Yes, general information about the implementation. Here, our study group is resource science teachers. It's almost 14 weeks duration. And we have part 1 and part 2 implementation process. And after these steps, we use some evaluation scale to assess our students' design. If we look at the part 1, design the future by engaging in scientific inquiry, we present a case to our students, and then we try to foster their creativity. For example, it's much more better to next one. Yes. For example, these questions are some examples of guidance to assist students are as follows. What do you think will change in educational venues such as classroom and school buildings in next 30 years? our students just try to design the future with current knowledge, scientific knowledge, and then they present us with their presentation, like or designing a model or simulation or a prototype or something else. And this, after this step, we present another case to our students. This is like that. Students often have trouble developing and managing an original project. Indeed, a certain skill set and level of experience are not needed to develop qualified projects. Accordingly, a number of strategies can be developed to be used by students who will work on the project for the first time. Students are asked to write down the first item that comes to on their mind or on a paper. These items can be anything from a table or book or something else. Next, the paper are folded and collected in a box, and the same process is followed for a material. And then students asked to write down the first material that comes to our mind on the piece of paper, and the paper are folded and collected in a box. Finally, students are asked to randomly select two papers, one from the items, one from the material box, and they use these items and materials for a new artifact. That's our second process. In the process, it's necessary to support our students. We used this engineering design process template. For example, ask, imagine, plan, create, test, improve states, all of them. They have to fill up everything in here. Then, after this process, we evaluate their design with this design evaluation scale. There's some qualification in the scale, but if you want to add another qualification, it's okay, because every design has its unique manner, and that means if you want to find another concept, you can just renew this scale. Yes, here's some example of the artifacts. For example, one item is door and the material is carpet in this design. And the students just sketch the design with the pencil or something else. He or she can use PC or web tools. And here, this design for the animals, especially in the winter, they can, it's hard to find some food for these animals. This is sustainable design, and some animals can come to eat this grain or herbs or else. Yes, here are the other examples of the artifacts. For example, the first one is pencil and wire. The process is just like that, and the features of the artifacts. Yes, final thoughts. In the integration of engineering design into classroom activities to encourage creative ideas, three principles are critical importance. The first one is emphasize on engineering design. The second one is STEM knowledge and skills. And the third one is incorporation of mind-on and hands-on activities. These activities, which are carried out with the understanding of the simple complex science, this is our motto, can trigger the enthusiasm of discovery in students' minds. Thank you.
Thank you very much.